Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Alhamdulillah rabbil alamin. Wassalatu wassalamu ala sayyidina Muhammadin wa ala alihi wasahbihi ajmain. Rabbi shrah li sadri wa yassir li amri wa 'uqdatam min lisani yafqahu qawli wa zidna ilma warzuqna fahma. Allahumma faqihna fi ta'wil. So welcome back to Fluid Mechanics class. Inshallah today we will continue our chapter on chapter 3.2. We'll be looking at Bernoulli Equation and its application. Okay, in this chapter you will be introduced to Bernoulli Equation and also the application and also the Venturi. The Venturi Meter is part of Bernoulli application. Okay, alright. So before we continue our class, let's recap back what we had learned in previous class. We had learned about conservation of mass. Okay, where the mass of or the density is remain constant over time, and the equation can be written as Q for volume flow rate. Q1 equal to Q2, where the unit is meter cubic per second. And we also have weight flow rate, where weight at point 1, the weight flow rate at point 1 equal to weight flow rate at point 2. The unit is Newton per second. And last one, we have the mass flow rate, where the mass flow rate at point 1 equal to the mass flow rate at point 2, where the unit is kilogram per second. Okay, all the three equations is called continuity equation. We also had learned about energy equation, where conservation of energy state that the energy E for an incompressible flow is the same at point 1 and point 2. For example, we have this kind of figure where we have a sudden contraction part, like in the figure. We can see that we have three types of energy, which is the elevation heads represent the potential energy, and we have a pressure head represent the flow energy, and we have velocity head represent the kinetic energy. So we have three types of energy at point 1, and also we have the same energy at point 2. Okay, we can see here that the total energy is the same for point 1 at point 2, but the value of energy for the kinetic energy is different. We have a larger kinetic energy at point 1 compared to point 2, and we have a smaller elevation energy at point 1 compared to point 2. Okay, this conservation of energy is also called as a Bernoulli equation, where we can write is as P1 over gamma plus V2 square over 2G plus Z2 equal to constant. Okay, why we call it constant? Because the total energy at point 1 is the same as energy at point 2. So since it's the same, so it's a constant. Okay, alright. So since the energy is conserved at point 1 and point 2, so we can also write the equation as P1 over gamma plus V1 square over 2G plus Z1 equal to P2 over gamma plus V2 square over 2G plus Z2. Okay, this is the energy balance equation. So please remember this equation. So you have three equations that in this chapter that have been introduced to you. The first equation is the continuity equation involving three equations: volume flow rate, weight flow rate, and mass flow rate. And the second equation is the energy equation, which is the Bernoulli equation. Okay, you always encounter this kind of problem involving Bernoulli equation and continuity equation. So please remember both equations. Okay, alright. So let's look at an example. Okay, we have a figure here, the same part as before. Okay, we have a pipe with a sudden expansion. Okay, where we can see here that the diameter of the pipe at point 1 is smaller compared to point 2. Okay, in this figure we have water at 10 degrees Celsius. So we are encounter problem involving water. It's flowing from section 1 to section 2. So water is flowing from section 1 to section 2 here. Okay, the diameter at section 1 is 25 mm. Okay, the diameter here is 25 mm. And the pressure is 345 kilopascal. Okay, the pressure here is 345 kilopascal, and the velocity is 3.0 meter per second. And at section 2, we have diameter at 50 mm. Okay, diameter is 50 mm, and the elevation from point 1 to point 2 is 2 meter. Okay, point 1 here, point 2, not from the reference level. Okay, not the elevation is not count from the reference level, but count from the point 1 to point 2. Okay, so assuming there are no energy losses. Okay, so the words no energy losses, assuming there are no energy losses, usually referring to the Bernoulli equation. Okay, in the system, calculate the pressure at point 2. Okay, let's we draw first the figure of the pipe. So we have a pipe, we have a sudden expansion here. This kind of pipe, sudden expansion. and we have reference level here. So this is our V1. So we have here V2. Sorry, this is elevation 2. We have V1 and we also have V1. We also have here V2. We also have here V2. So the flow is flowing from point 1 to point 2. So this is our 1. So 2. Okay, so how we solve this question? First, you need to find the unknown and known. So the known here is pressure. Pressure is given us at 300 at 45 kilopascal, and the velocity is 3.0 meter per second, and also given us the diameter. Diameter at point 1 is 25 mm, and diameter at point 2 is 50 mm. So if they are giving you the unit in mm, you need to change it into SI unit in meter, which is 0.25 meter, and this will become diameter point 2 will become 0.05 meter. What else given to us is the elevation from point 1 to point 2 is 2 meter. It's 2 meter. Okay, as I said before, if you are involving the problem they are giving to you involving pressure head, velocity head, and elevation head, this is referring to the Bernoulli equation. So you need to solve it using Bernoulli equation. So let us write the Bernoulli equation. We have P1 over gamma plus V1 square over 2G plus Z1 equal to P2 over gamma plus V2 square over 2G plus Z2. Okay, and then we have this kind of equation. But before you're solving the equation, first you need to symbolize the equation. Okay, considering that the point 1 is our reference level, so we can cancel out the Z1. Since we are measuring the height from point 1, so point 1 is our reference level, so reference level is 0 until point 2 is 2 meter. Okay, what is given to us in the equation? So the first one is you need to symbolize the equation. The second one is you need to find the known and the unknown. Okay, the known is here is they had given us the value of P1 and also V1. And this question they want us to find P2, the value of P2. What's the value of P2? And we have another problem because we doesn't know the value of V2. We doesn't know the value of V2. Z2 is given to us, which is 2 meter. So how we find the value of V2? Okay, since they are given the value of the diameter of the pipe, we can use continuity equation Q1 equal to Q2 A1 V1 equal to A2 V2 to find the value of V2. So you can rewrite the equation as V2 equal to A1 over A2 V1. Okay, we know that A1 is equal to pi R1 square or A2 pi R2 square. So we can simplify the equation as R1 square over R2 square V1. Okay, the value of V1 is given to us here. R1 is given to us and R2 is also given to us. Okay, you need to find. So you can find the V2. When you find the V2, you can solve P2. So this is your first homework. Please find the value of P2. Okay, and submit it. Okay, alright. Now, okay, this solution is here. I will give you a slide later. Okay, now we also encounter this kind of problem. Okay, this kind of problem I already show you in the previous videos in the tutorial section. Okay, you can refer the tutorial section if you want to find the solution for this kind of problem. Okay, alright. Now we'll be looking at Venturi Meter. Okay, Venturi Meter is you must remember that Venturi Meter is part of Bernoulli Equation application. Okay, where is the Venturi is used to find the velocity of a flow. Okay, so we have two kind of operators that we had looked at before. The first is manometer in chapter 2. Manometer. Okay, manometer is used to measure pressure. And then we have Venturi meter. Venturi meter is used to measure velocity of flow. Okay, of fluid. Okay, please remember. Alright, so what is Venturi meter? Okay, you can see here this we have a part, and then the part have a sudden contraction, and then the pipe become large again. Okay, and attached to the pipe is the manometer. Okay, here is manometer. We know this is manometer because okay, inside manometer we have manometric fluid. Okay, here the color is a bit different. Okay, from the water. Okay, alright. So the sudden contraction here is actually we call it Venturi meter. So if we write it as like this, we have a pipe. So we have a pipe, and then you find sudden contraction. We have pipe and sudden contraction. Okay, the contraction here is Venturi meter. Venturi meter. Okay, Venturi meter usually is used with manometer. So usually connected to manometer. Alright, so we have here manometer. Inside manometer we have manometric fluid. Okay, we have this kind. So, right, and we have a hole here. Okay, this is Venturi meter, and it is manometer. Manometer. Okay, this device is part of Bernoulli application. Okay, Venturi meter is usually used with manometer. Okay, as I said before, please refer to your notes. Okay, and since this device is part of Bernoulli application, so we are using Bernoulli equation to solve this problem. Okay, alright. So let's look at example. Okay, we have example here where the Venturi meter shown in the figure carries water at 60 degrees Celsius. The specific gravity of the gauge fluid in the manometer is 1.25. Okay, this is referring to the gauge fluid here inside here. Okay, and then calculate the velocity of flow at section A and the volume flow rate of the water. Okay, what is given to us? First of all, what's given to us is in this figure we have inside the meter is the contraction is 200 mm, and the inside diameter of the pipe is 300 mm. The elevation from point 1 to point 2 is 0.6 meter, and then we have here the unknown elevation from the manometric fluid level here to the point A is y, and then we have here the elevation of the manometric fluid 1.18 meter. Alright, so let's we write it here. So we have a Venturi meter. This Venturi meter. The Venturi meter is connected to a pipe, connected to a pipe. Okay, looking at this, and then here we have sorry, we have manometer. My picture is not very good. Alright, so here we have manometric fluid. For example, here this is your point A. The picture is not alright. So we have here point A, and then we have here point B. Okay, the inside diameter of the Venturi meter is 200 mm. Okay, the inside diameter of the pipe is 300 mm. Okay, the elevation from point A to point B is 0.6 meter. Okay, the elevation from point A to the manometric level here is y, and the elevation of the manometric fluid is 1.18 meter. If I'm not mistaken. Okay, we have here. So the question want us to find the velocity of the flow at section A. So they want us to find VA. What is the value of VA? And then the volume flow rate. So they want us to find the Q. Okay, how we can find it? Okay, what is given to us and not given to us. First of all, you list what is given to you and not given to you. So what is given to you is dA. dA is equal to 0.3 meter, and we have dB equal to 0.2 meter, and then we have the elevation here, Z1, ZB minus ZA. Okay, the elevation difference between point A and point B is 0.46 meter. Okay, what else we have? And then do we have V1? So we do not have V1. Do you have V2? V2? Sorry, do you have VA? No, we don't have VA because we want to find VA. So do we have VB? We also doesn't have VB. Okay, do we have pressure at point 1? We also doesn't have pressure at point 1. Do we have pressure at point 2? We also doesn't have pressure at point 2. Okay, so what else we have? We only have the elevation here. So how we are going to solve this kind of problem? Okay, actually we can solve it by combining the solution of manometer and the continuity equation. Okay, to solve the problems you need three equations. First equation is the continuity equation. Continuity equation. Second, you need manometer equation. Manometer equation. And third one, you need Bernoulli equation. Bernoulli equation. So you need to combine all the three equations in order to find VA and Q. Okay. Okay, what is the use of continuity equation? Okay, continuity equation we can use it to find the velocity. Okay, manometer equation we can use it to find the pressure difference point A and point 2. Sorry, this is point A, point B. And the last one, Bernoulli equation, is we use it to find to solve our problem, which is VA. Okay, so this is the combination. Venturi problems is combination of the three equation. Okay, right? Combination of the three equation. So let us solve this problem. So First of all, let's we write the Bernoulli equation. Since we are solving this problem using Bernoulli equation, so we have Bernoulli equation PA over gamma plus VA square over 2G plus ZA equal to PB over gamma plus VB square over 2G plus ZB. Okay, so now let's separate pressure with pressure, velocity with velocity, and the elevation with elevation. So we have PA minus PB over gamma plus VA square minus VB square over 2G equal to ZB minus ZA. Okay, we have here. So ZB minus ZA is, we already have the value, which is 0.6, 0.46 meter. Okay, all of this is unknown to us, unknown to us. Gamma, you can find it using rho g. Okay, rho, where rho is 1000, g is 9.81. Okay, so how we find PA and PB? Like I said before, we are using three types of equation, where continuity equation, manometer equation, and the Bernoulli equation. Okay, now let's first look at the easy one, the easy part, which is continuity equation. Continuity equation, where Q1 equal to Q2, so AA VA equal to AB VB. Okay, A is given to us because they have already given us the diameter of at point A 300 mm or 0.3 meter. They also have given us diameter at point B, where 200 mm equal to 0.2 meter. So you can find VA, but what unknown to is VA and VB. So since we want to find, the question is want to find what is the value at of VA. So we need to know what is the, so we need to change the equation. So what is the value of VA? VB equal to AA over AB VA. Why we need VB? Because we want to substitute the value of VB in this equation into VA. Okay, when you substitute the value of VB into VA, and then we can factorize the VA, and we can find the value of, we can find the value of VA. Okay, now we are already done with this problem. So let's substitute the equation inside the Bernoulli equation. So we have here P1 minus, PA minus PB over gamma plus, so we have VA square minus, okay, since here it's supposed to be VB, so since VB is equal to AA over AB times VA, so we can just AA minus AB VA, and don't forget the square, over 2G equal to ZB minus ZA. And we have this kind of problems. And then, like I said before, we want to find VA, so you can factorize the VA. So also you can write this part. Okay, but here you can write it as VA square 1 minus A2 AA square AB square right? And then over 2G. Okay, you can also write S like this lah. Okay. Okay, now we have already solved this section of the velocity head. Now let's solve the section of the manometer, where elevation head. So we have manometer looking like this, point A here, point B here. Okay, looking like this. Okay, this is where the manometric fluid ends, and then we have to start another one here from here. Okay, elevation from point A to point B is 0.46 meter. Okay, if you doesn't understand this kind of figure, please refer to the figure in your notes. You see Y here, and then we have here 1.18 meter. Okay, Bernoulli equation, we had learned that before in manometric equation. We have to determine our starting point and our end point. For example, my starting point is A, so moving downward, plus, then I move it upward again, A, minus, and moving upward again, the minus, and then move it upward again, and then minus. So we have this kind of manometer equation. So first of all, let's write it as PA plus. So inside this here, from A to manometric fluid level, here is water, so raw water, G H1 minus raw manometric fluid M G H2. Here to here is water, so minus raw water G H3, and then water again, minus raw water GH4 equal to PB. So PB. So inside our equation is PA minus PB. So since PA minus PB, so let's rewrite our equation as PA minus PB equal to raw mercury GH2 minus raw water GH3, plus raw water GH3 plus raw water GH4 minus raw water GH1. Okay, what is H1? So H1 here is elevation from point 1 to water, the manometric level here. So what is the elevation? Y plus 1.18. So H1 is Y plus 1.18 meter. What is H2? H2 here is 1.18 meter. And what is H3? H3 is here Y plus H3 equal to Y. H4 is 0.6 meter. H4 is 0.46 meter. So you substitute the value of H inside the equation, will become raw mercury G, since H2 H2, so 1.18 meter, plus raw water H3, here is Y, G Y, and then we have H4, so raw water G 0.46 meter, and then we have another one minus. Okay, we have here raw, so let's have here raw water G H1 is Y plus 1.118. Okay, so Y is unknown value, but since raw water Gy, we also have here raw water Gy. This is plus, and this is minus. So we can cancel out here the value here. So what left here is raw manometric fluid G times 1.18, raw water G times 0.6, and we have here raw water G plus 1.18 only. Since we already cancel out the value of y. So what left us from PA, PB is PA minus PB equal to rho manometric fluid G 1.18. So and then we have plus rho water G 0.46, and then we have minus rho water G 1.18 meter. Okay, so we can solve the rho. So we have rho mercury. They have given, so rho manometric fluid given us 1.25 the SG. So you need to find the rho. So the rho is equal to 1250. Okay, rho water is 1000. Here also is 1000. Okay, G is 9.81. So you can find the value of PA minus PB. Okay, so if you find the value of PA minus PB, you can substitute the value inside this equation. PA minus PB equal gamma plus VA square minus, okay, inside here we have AA square plus AB square VA over 2G equal to VB minus VA. So from here, you can solve the value of VA. Okay, VA, what is the value of VA? Okay, after you solve the value of VA, you can use the equation Q equal to, Q equal to AA VA to find the volume flow rate. So you can solve it here. So you need to solve it yourself. You need to solve it yourself. This is your second homework lah. Second homework. Okay, this kind of problem is a bit difficult, but we can solve it step by step lah. Okay, step by step. Okay, alright. So that's how you solve this kind of problem. Okay, example, I will giving you this solution there, so you can look it back. Okay, alright. So I think that's all for today. Yes, that's all for today. As for your second, the last homework is this. Okay, is here. This kind of problem, I will show you in tutorial video how to solve it, but you need to solve it yourself. So you have three types of problem that you need to solve it yourself. The first problem is this problem. Okay, you need to find the value. The value of the, assuming calculate the pressure at point 2. So you need to find the value of pressure 2. And the second homework is you need to find the velocity of flow at section A and the volume flow rate at section in the pipe. Okay, and the last one, if you need to solve this problem. Okay, alright. Since I'm giving you a lot of homework, so you just need to submit this all your homework by next class. Okay, so your next class will be, so you just submit it by by next class. Okay, no need to submit it by today. Okay, so that's all. So no need to submit it by today. I giving you the time until next week to submit your homework. So thank you for listening. Assalamualaikum warahmatullahi wabarakatuh.